Welcome back, friends. Now in this lecture we will solve one another type of numerical on determination of main dimensions. So first we will read the example. Find the main dimensions of a 100 kilowatt 3 phase 3300 volts 50 hertz 12 pole squirrel cage induction motor having an efficiency of 90% and full load power factor of 0.9. Assume specific magnetic loading 0.4 Weber per meter square and specific electric loading 25,000 ampere conductor per meter. Assume winding factor 0.96 and choose design to give a based power factor. Now if you read this example carefully, then the example is much similar to the examples we have already solved in the previous lectures, but here is only a small change, that we need to find the main dimensions, that is D and L, at a new constraint, and this constraint is we need to find this main dimension which gives a based power factor. Now previously we have solved the examples at the different constraints, like if the particular velocity is given, peripheral speed is given, or if we want to find the main dimensions which gives a cheap design or overall good design or the good efficiency. But now in this example we are having a one another new constraint, and that constraint is now we need to determine the main dimension which gives the based power factor. So already I told that in the examples of the determination of main dimensions, the procedure up to the calculation of d square L is same. So first we will read the once again example carefully, and then we will write the given data. So the kilowatt is given 100 kilowatt, frequency is 50 hertz, number of poles are 12. So if you calculate here again by using the NS is equals to 120 F divided by P, and if you put here the F is 50 hertz and P is the 12, then you will get the NS is equals to 500 RPM. Now the efficiency is given 90%, cos phi is in power factor is 0.9, and the specific magnetic loading 0.4 Weber per meter square, and the ampere conductor per meter, that is AC, is 25,000, and it is also given here the winding factor, that is Kw is equals to 0.96, and we need to calculate the D and L which gives the based power factor. Now first we will calculate the D square L, and for that purpose we will use the output equation, and the output equation is D square L is equals to kVA divided by CO into NS, where this CO is having this expression, that is 1.11 into kW into BAV into AC into pi square into 10 to the power minus 3, and kVA is the kW divided by efficiency into cos phi, and in these two equations whatever be the quantities we require to calculate all are given. So just we will insert these given values in these two equations, and we will calculate the kVA and CO. So first we will calculate the kVA. So the kVA is equals to kilowatt divided by efficiency into cos phi. So kilowatt is 100 divided by efficiency is 0.9 into the power factor is 0.9, and if you calculate this you will get 123.5. similarly, we will calculate the CO also. So CO is equals to 1.11 into 0.96, this is kW, into 0.4, this is BAV, 25,000 is AC into pi square into 10 to the power minus 3, and if you calculate this you will get the 105.6. Also, it is given here the capital NS is equals to 500 RPM. So, if you convert in the RPS, then the small ns becomes 500 divided by 60, and you will get this value 8.33. So, just we will put this value of the kVA, the CO and the ns in the expression of the d square L. So, you will get here the 123.5 divided by 105.6 into 8.33, that is 140.4 into 10 to the power minus 3. Now, after calculating this d square L, the next step is separate the d and L from the product d square L. And while separating this, we need to take one thing under the consideration, that we need to find the D and L which gives the best power factor. And I have already told in the lecture 3 that the condition for the best power factor, and the condition for the best power factor is the tau is equals to 0.41 into under root L. So, if you take this value of the tau, then the design or whatever with the D and L we are getting, by this consideration we will get the best power factor design. As we know that the tau is equals to pi d divided by p. So, if you put here, then the equation becomes the pi d divided by p is equals to 0.41 into under root L. So, from this equation, if you calculate the value of the D, then you will get the D is equals to 1.56 into under root L. So, this equation you will get D is equals to 1.56 into under root L. Now, if you put this value of the D in the equation 1, then before inserting this value in the equation 1, because if we are having the D is equals to 1.56 under root L, then you can write the value of the D square directly, because we are having the equation 1 in the terms of the D square. So, it is easier instead of putting the D square value. So, the D square is equals to 2.45 L, and if you put this value of the D square in the equation 1 here, then this equation becomes 2.45 L square, because this L is already present here and this L is another one L. So, L square becomes there. So, the 2.45 L square is equals to 140.4 into 10 to the power minus 3. And from this equation, if you calculate here the value of L, then the L is equals to 0.239. And then this value of the L we will put in the equation number 2 here to get the value of the D. So, the D is equals to 1.56 into under root L, and if you put in this equation L is equals to 0.239 from this value, then you will get the D is equals to 0.76 meter. Now, as we have here assumed for the best power factor, the value of the tau is equals to 0.41 into under root L, then just we will check this for the peripheral speed. So, we have calculated here the D is equals to 0.76 and L is equals to 0.239, and if you calculate the peripheral speed by using this equation pi d ns, then the pi into 0.76 into ns, that is 8.33, you will get this 19.88 meter per second, and it is below than 30 meter per second. So, this speed is within the range. So, that is why whatever with the D and L we have calculated in this example, it is acceptable. So, the final answer becomes the D is equals to 0.76 meter and L is equals to 0.239 meter. So friends, so whenever in the example it is asked to find the main dimensions to give the best power factor, then just you have to put, while separating the D and L from the D square L product, the tau is equals to 0.41 into under root L, and you have to be calculate the value of the D and L by considering this equation. So this is the only change in this example. So similar type of examples I have asked in the exercise. So I hope you will solve these exercise at home and submit me. Thanks for watching.